Okay, so today we're going to look at loan payment one. So if you're looking at your formula sheets for your financial math, we're now going to move down into the loan payment formula sheet. So let me just.
K-12, we're going to do a few outside activities. If you can meet me outside of the school at the self-entrance, I will direct you with you for the next 45 minutes to an hour or so.
Okay, so that we're going to be looking at this part right here. The second, the loan payments and mortgage and borrowing today. Okay, we missed a few days, so I'll do the. Hopefully this will work out all right for me to do it online for you. Okay, so what are we going to do today? Okay, we are going to look. We're going to look at loan payments and mortgages. Okay, that's what we're going to look at. Okay, this is not in our textbook very well. So what I'm going to do is do the examples and then I'll have a practice sheet. So there'll be a practice sheet with posts. Okay, so we'll do a practice sheet that won't count for marks, just for some practice sheets. So just to remind ourselves what all those symbols mean, the R, okay, that's the size of the payment. Okay, the principal. Amount of the loan. Okay, the interest rate per period is a little I. Okay, and the number of periods is N. Okay, so that's our stuff that we would be, our variables, not our stuff, our variables. Okay, and just remember that this is on your formula sheets. Okay, so we're going to do about 3 or 4 examples of that today. And then I do have the practice sheets. I'll either give them out at the, get Mrs. Seneca to give them out at the end of the class, or maybe I'll do it the next day, depending how long this video goes here today. Okay, so let's start out with like a car loan example. That's a common example. So, okay, so I borrow, let's say $32,000 for a car at 1.8% compounded monthly. Okay, that's the idea. What is the size of my loan payment? Okay, so we're going to be looking for R. If I extend it over 5 years. Okay, so take a look at our sheet. There we have, we're going to be using the second, well, the very under loan payments, the second one for R. So that one there. So let's define all our variables first. Okay, so that's the first thing we're going to do. Move that up there. Okay, we want to get our I value. Okay, our I is the interest per period. So we've got 0.018 for our per year, and there's 12 months a year. So we got to divide it by 12. Okay, that's 0.0015. Okay, now there's 5 years, so 5 years a month. So our end value is 5 years times 12 months a year to get 60 months. Okay, and then we need to also know what our principal amount is, and that's we want to borrow $32,000. Okay, and I might add in here, how much interest did I pay? Just to have a couple questions. Okay, so we're going to use the equation for R. So R equals, now we're doing the loan payment one. So just remember, when you're doing the loan payment one, you have to have the negative end value, because we're doing loans now, not the positive one where we're investing. So this is a different formula. So this is P times I, all divided by, in brackets, 1 minus 1 plus n in round brackets to the negative n square root. Okay, so working on our calculator, 32,000 for P, 0.0015 for I, okay, that's what we got to work on. So we'll work out the top first. That's 48. Okay, then what you would do is you'd combine the 1 plus the interest rate and take it to the power of negative 60. So make sure you're using the plus minus symbol on your calculator, not the minus symbol when you're going with that one there, when you're going with this. So I go 1.0015 to the power of negative 60. Okay, and I get that decimal number, and then I subtract it from 1. So one way that you can subtract it from 1 is just put a minus in front of this, and then add it if you want. Or you can just 1.015 to the power of, I kind of erased it there. Take that number and you could just easily just subtract 1 from it. And then that would be your answer, but in a positive form. So then you would just divide that number into 48. All right. 0.0, what is it? 8600, and you don't want to round off very much. I would just leave it on your calculator and put it in memory and just divide it out. So when you do that, you get a payment size of $558.09. There's our payment size. Now the second question asks, what is our interest that we paid? So our principal, we know, is 32,000, whatever. But we have to kind of figure out how much do we pay future value-wise. Well, that's 60 payments of this. So 60 times $558.09. Okay, when we do that, we get 33,485.40. Okay, and the interest is just the difference between these two. Okay, when we do that, we end up getting $1,485 and 40 cents. So that's how much interest you have to pay. And this is the size of your payment. Okay, so that's a typical car loan type problem. Okay, lots of those. Okay, the next one that we're going to do is an example of a mortgage payment including a down payment. So we're going to do a mortgage one next. Okay, so let's do a mortgage example. Let's say that I'm going to take out a mortgage here. Let's set one up here. All right, let's change colors here. I'm typing. All right, so let's say I take out a mortgage on a house with a price of, let's say, $185,000. Okay? The bank requires a 10% down payment. Get my head out of the way. Okay. And I get a 10-year term. Okay. The rest, let's say, is borrowed on a 10-year term. Okay, at 3.4% compounded monthly. Okay? And so what would the size of the monthly mortgage payment be? Okay, so we're going to figure that out, but we're also going to figure out a couple other things here as well. Okay, what kind of a payment do we have? And let's ask, say, also, how much interest did I pay over the mortgage? We'll say during Okay, so we'll kind of do those kind of similar to the first one. So this is the very same type of problem in the sense that you're still paying, looking for a size of regular payment here. Okay, so let's take a look at that. We'll start off, we're still going to use that calculation for R, but we'll start off by defining everything. First thing is we got to take off this 10% down payment. Even though you still have to pay that for the house, it's not something you're borrowing, so that doesn't go into your interest. So you've got to take that off your principal amount. So 10% of $185,000. Okay? So 10% times that, it's pretty easy. It's just $18,500. So we've got to borrow $85,000, subtract 18,500. So we still need to borrow 166,500. Okay, so that's what we're going to borrow. Now, that's going to be our principal amount. Okay, and we're going to borrow it over a 10-year period of months. So principal amount we've got, figure out our interest rate. Our interest rate per period is 0.034, and we have to divide that by 12. Okay? You take your calculator out, 0.034 divided by 12. Okay, we've got a repeating decimal on there, so we're going to have to be careful when we use it that we keep all those values. Okay, and then of course, how many months are in 10 years? We've got 120. Okay, so we've got to figure out what our size of our payment's going to be. So that's just going to be the principal times the interest rate and now my interest rate is still on there, so I can still multiply that out. And then I've got, of course, 1 minus 1 plus to the negative 120. Okay, so I've got that on there. So I might as well just multiply that by 166,500. And I get 471.75 on the top. Okay, which works out to a nice round number. Okay, and then I'm going to have to do this. So now, what I recommend doing here is I'd go back in my calculator and I would go 0.034 divided by 12 to get my interest rate back, and then add 1. Okay, then I would raise that up to negative 120. So I'd go to the power of negative 120. Okay, and I get that. And then I would just subtract it from 1. So I get that in a positive way. So I get 0.287887405, and then I just divide those. On my calculator. Okay, and I get $1,638 and 66 cents. Okay? So that's the regular payment size that I have. Okay, so that's what I'm gonna have to be paying for my mortgage. It's only 10-year mortgage, so pretty high, but not bad. Okay, now what is my interest? So I've got to take this value and multiply it by 120 months. Remember, you didn't have to include the down payment because that you have to save up yourself. Okay, so take this $1,638.66 and multiply by $120 or 120 months. So I get $196,639.20. Okay, so that's my that was my amount that I've paid, my total amount that I've paid. And then I'm going to subtract my principal amount. Okay, so just take this and go minus 166,500. Okay, so I've paid over the 10 years $30,000 worth of interest. For that house over 10 years. Okay, so there's both of those questions are very similar in that you have to find the regular payment size. So now we're going to go back and we're going to look at the top equation. Now the top equation, that's where it says you want to find P, or the present value, or the principal, or whatever. So the example that we're going to do now is finding the amount that you can borrow based on the size of the payment you want to make. Okay, so that's what we're going to do in this example. Okay, so this is going to be okay. This would be an example. How much you can borrow based on the size of the payment you can make. Okay, and finding interest and all that other stuff can be involved in there. Okay, so let's say that I know I can make a payment of $300 a month. Okay. Over the next 4 years. Okay. What is the size of the loan I can take out from the bank if they offer me? And what is the max loan amount I can borrow at, let's say, 4.8% compounded monthly over the 4 years? Question mark. Okay, so this is the one where we're going to do the other equation now, finding the p value or the principal that you can borrow based on what you can pay in terms of payment sizes. So first thing we got to do is figure out this interest rate thing again. Okay, R is $300. I is 0.0.48, and that's per month, so divided by 12. Okay, and then when you get the interest rate, that's 0.004. Okay, and there are, in 4 years, there are 12 months a year, so 4 times 12 months in the 4 years total for 48 months. Okay, so now what we do is we just plug it in, but we're using this one, P equals R, and then that whole, remember that this is the loan one, so you need the negative N up there, like that, and then you need I on the bottom. Okay, so 300. Our interest rate added to the 1 to the power of negative, what was it again, 48. Okay, take our calculator out. 1.004 to the power of negative 48. Okay, subtract that from 1. Okay, and then multiply that by 300. Okay, and then divide by, I almost forgot to divide by the interest rate. So I ended up with 52.31 on the top, and I'm going to divide by 0.004. Okay, I get $13,078 and 27 cents. So that's the maximum amount of money I can borrow at that particular rate. Okay, and if I'm wanting to find interest, well, I'm paying $300 a month for 4 years, so 300 times 48 months. So that's 14,400 minus 13,078.24. So I'm going to get I pay about $1,321.76 in interest if I ask that. Okay, we'll do one more. And then I'll leave you with
Beam to the office, please. Beam pause next to the office.
a sheet. Okay, so now we can do an example question so we can compare to. Is the other type that comes up. Okay, so let's compare one. Okay, so compare question. Let's say I need to borrow $1,000. What are the sizes of the payments for each option? Okay, so let's say you do a one-time payment over 12 months. Or a year. Oops. At 8.4%. Or I could do a monthly payment over 12 months. Okay, at, let's say, a lower interest rate. Okay, so the first one is a single payment. So that means you're not going to use the regular payment stuff. You're just going to use the compound interest formula at the top. So you're just going to use the future value. Okay, that's P1 plus I to the power of N. Okay, we got to do this. We'll figure what I is. I equals 0.084. And since it's a one-time payment over a year, you don't have to divide by anything because it's not compounded. It's a one-time payment. So that should make it cheaper, but it's a higher interest rate. So our principal amount is 1,000. So what are you going to end up having to pay? And our months are 12 months. Okay, so 1,000 times 1.0084 and 12 months. 1.0084. Or no, sorry. 1.084, not 2 zeros. So there we go. Okay, power of 12. Actually, it wouldn't be 12 because we're not doing it per month. It's a one-time payment. This would only be one. My mistake. We're not paying every month. That's the second one. So the first one would only be one payment. Because you're paying it one time at the end of the year. Okay, so that would be pretty easy. Just take the 1.084 and times it by 1,000. $1,084. Okay, the one with compound interest has a cheaper interest rate, but will we have a different payment size? Yes, so we have to get our payment here. It's regular payments So it's going to be this formula here. All right, so let's get their interest rate here. 0.068, and we have to divide that by 12. Okay, that's 0.08379, etc., etc. Okay, and then the number of periods, this time we have 12 months. So we're going to raise that, add 1 to it. And then raise it to the power of -12. And then we're going to subtract that from 1. So our bottom part is our top part, sorry, 5.66666, and our bottom point .6192. Okay, so now we can just divide. And we get about, let me check this bottom number again. I don't think that one turned out right there. No, that's because this one is 0.0056 repeating. That's what our interest rate was. I had the wrong one in the bottom. Let me rewrite that part. Okay, so let me do that again. That one there, plus 1, raised to the power of -12. There we go, that's better. Minus from 1, divided by 5.66666. All right, and when I do that, I get $86.43. There we go. Okay, so there's our examples for today. So I will also put up some practice ones. I'll give Mrs. Seneca the sheets to hand to you, but I'll also put them up on the website here as well. And then the solutions I'll put up on the website as well. Good luck.